Okay, privacy for tigers. Eventually this will work. Never mind, something. So this is particularly I'm going to talk about security and privacy challenges and conservation when we look at crowdsourced image data. So this is in addition to the IBIS team, which I already have mentioned, which includes Dan Rubenstein, the ecologist from Princeton, Chuck Stewart, who is the computer vision scientist behind all the zebra identification and other animals, and Jason Holmberg from Wild Me, and Drew, who was around and gave a talk earlier. This whole project, part of the project, is in collaboration with Ross Anderson from Cambridge University, who is a privacy and security privacy expert, and the Center for Trustworthy Scientific Cyber Infrastructure. Yes. Jim Bassney is representing this and going to talk a little more about it. I'm just going to set him up and let him do the work. Okay. So clearly poaching and wildlife trafficking is not a new problem. Thank you, Nicole, for giving a wonderful introduction about this terrible subject. So giving the numbers a little bit. But so there's also the very recent World Wildlife Crime Report that just came out and gives a little bit more of the numbers. There are numbers, sort of, but they also talk about the problem of collecting those numbers and how inaccurate they probably are, and sort of this, and what the definition of wildlife crime is in the first place. So just it's not a new problem. So not all of it is related to security and privacy with of software and technology that we're developing. Most of it happened long before technology was brought in the field. So rhinos are an example which. The numbers are just devastating every time you look at it. They decrease. So like the Javan rhino, 58, 61, right? The northern white rhino, there were 6 left in the world. We saw Sudan, male rhino die in our lifetime in the last 2 years. So we have pictures of him. Now we don't have the rhino, right? So it's really not a new problem. Most of it happened long before technology, but with the data, the amount of data that we have now, particularly with images, and the crowd that's involved now in collecting those data and consuming those data and sort of contributing to this, which is great. And I gave a talk yesterday how great it is for science and conservation, and eBird is a great example of what crowdsourcing can do for science and conservation. It's terrible for wildlife crime. Because now you have a lot more data, which can be a lot more accurate, with lots of more vulnerabilities, with images, which are the prevalent data of about wildlife on social media. It opens up so many more points of sort of vulnerability and threat points, and I'll talk a little bit more about that. But we can also leverage it, being aware of it, for wildlife crime prevention, and I'll talk a little bit about that too. So just to sort of demonstrate what is it that I'm talking about, here's an example from IUCN. Okay, ask me later, hopefully. So this is, no? It's not, I might have.
Oh, you're on the internet. Okay.
Yeah, I'm on the internet. Okay.
You want to see them both.
But it's not loading for some reason. Okay. I might have to do my own, but yes. I can switch to my laptop quickly. So yeah. This so to show the data that is with snow leopards. It's just not happening. Well, no. It's not loading somehow here. I'll prepare and I'll show offline later. But so IUCN, which is an international body that determines the sort of threat levels of whether it's threatened, endangered, and so on for different species. And Lucas knows very well because he contributed to a lot of these maps that I'm trying to show. If you go to this, to the website, for example, for snow leopards, which I was trying to show, not only you'll see the range of where snow leopards are found on that map right away, open, and because they're found in some cases in such tiny constrained regions, it can pinpoint the locations of snow leopards pretty down to, you know, a size of campus, which is very helpful if you want to find a snow leopard. Right? You also can look at images, and I was trying to say, you look at all images of snow leopards from some area. It links to or you can look to images of snow leopards. With our technology, you can now start identifying these images. I've already looking at images that it's linked. I was like, oh, that's the same one right away there. And by looking where and when they were taken, you can start zooming in sort of on where these leopard likes being, and so on and so forth. Could be very, very helpful for poachers, for example. So the data-driven, this aspect, both the fact that it's the images, but also that it's data-driven, now science and data-enabled science and conservation brings up issues that are very common to both the human security and privacy issues when we switch to massive amounts of data and wildlife. So there are many parallels that we're now coming up against in wildlife that have been already considered for humans. So there's the insider threats, obviously, which if you have poaching, majority of the poaching is done by somebody who is on the inside. Majority of the poaching data, is disclosed by somebody who is on the inside, and and doesn't even have to be intentional. With the advent of cell phones, the rangers checking their Facebook while they're walking around, and that points location of the rangers. So insider threat is maybe intentional or not. Jurisdictional tangles, animals are not quite often aware of the fact that here's the end of the nature preserve and the beginning of the next one, or even a political border between two countries, right, that also have very different, so who owns the data on that animal? Who owns the data of that whale, or the sea turtle, or the zebra, or the rhino? Well, rhinos are typically within one preserve, or the elephant, right, that crosses 3 countries over the course of the year. So not only who owns that data, but different countries have different policies about disclosure of the data and what can and cannot be posted, for example, on social media, including photographs. And it's similar for humans, so there is privacy, very different privacy regulations between US and Europe, for example, of what can be posted and what data can or cannot be disclosed, even to things that one would think are pretty well regulated, such as health records. But they're regulated differently in different countries, and so the medical data, if you move or if you cross borders, can be treated very differently. So, and for animals, again, we have the same kind of nightmare and jurisdictional nightmares. Multi-level policies that sort of different types of data are hierarchically or in parallel or in overlap covered by different types of policies, and access is given to, I'll talk a little bit more about it, access is given by to some part of data to some individuals but not others, and so there's this consistency that has to be maintained. Secondary use hazards, so if you derive data from your primary data, so if you derive some insight from your primary data and then use it, that can pose risks. For example, in human data that was combining publicly available data on on location, searches, right? Searches, tweets, and so on. You can find health records and health information that somebody's did not probably want to disclose. Good uses of the same kind of data is that you can sort of estimate the prevalence of flu by using tweets and searches, combining tweets and searches. So for animals, clearly secondary use hazards are amplified because by disclosing such as home range, right, or presence of snow leopard in a particular area once it's, or their prey. So for snow leopards, it's much harder to track snow leopards than tahr, the goat, the blue goat, which is their prey. And you can very accurately, so Som Ali, from a scientist from the Snow Leopard Conservancy, did his entire PhD on how you track snow leopards very accurately by tracking their prey. So by tracking the prey, in disclosing information about the prey, you essentially have disclosed information about the snow leopards. 5 minutes. Okay. There is covert channel geofencing, security economics, very nice talks before, and usability. You can come up with all kinds of security policies and privacy policies, but if they're not usable and implementable, they're not going to be. So not only that, while there are many parallels, and one would think we've resolved these questions in the human domain, there are additional challenges in the wildlife domain is that the policy is completely stuck in the 20th century in the animal domain. We also don't even have the very first step that you need, the definition of public and private. So all of us, when we appear in public, if somebody takes our picture, it can be posted. We don't, in US, right? We don't have the right to remove it unless we're celebrities, right? There's right.
Maybe academics aren't.
Right. But there is a notion of private domain, so that we have no right to photograph humans in their home and then post their pictures, right? That's peeping Tom. But stalking, there's a definition of stalking. So for animals, there is no notion of that. There is no policy. There is no definition what is private, what is public. And so therefore, there is no policy that applies. So, okay, for wildlife crime, there is the good. We can use this crowdsource images and the system that will identify individuals to track threatened animals, to do forensics, identify animals that have been killed, and hide that is illegally sold that has been asked a couple of times of us. So can we identify tiger from the temple, the temple that was, I don't know if you heard, that has been sold? Yes, we can, by photographs. So we also can prevent illegal pet sale and wildlife trafficking. So we have a project with geometric tortoises that there is legal pet sale, but there is also wild population, which is illegal to be sold. So by taking a picture, you can say, okay, this is the one, is the wild ones. So that's all great. The bad is that now a lot of people are going to these nature preserves or whale watching or turtle watching, and take pictures, and there are several issues here. One is if they take pictures of an endangered animal and post it, fantastic, right? Poacher's delight. So now a lot of preserves will close it. Please be careful, do not geotag. But it's not enough to even not just geotag. Your phone, when you're taking this picture, is disclosing a lot more information about you. Even if you're not posting that picture already, it can be listened to all the cybersecurity threats that are common, that we know already. There's also, in addition to that, even if you're taking a picture of not endangered animal, but of a giraffe, we can know where the lions are and the leopards are, right? So we can talk about different cybersecurity policies that are there, such as, we can install that it's multi-level, that information can only follow up, but there's, now only a small group of individuals to all the information, which is a problem, right? So there is compartmented, which is like the health records. The information does not flow sideways, but it's a problem because there's all the vulnerabilities of the usual, hacking plus the lack of cooperation, which misses the information. There's statistical disclosure control, which is obfuscation through aggregation and so on and so forth. But the problem, once you have big data, you can augment and de-identify, and we don't understand yet enough of what can be done. And so the ugly part of this, I'll just mention it, that there's consistency in this data. So let's say you have I'm a conservancy that I have my own set of images for one individual, which the edge decision was made pairwise, and you have your own, and you know that this is your individual. And then comes the citizen scientist with a picture, and it's matched both to one of mine and one of yours. And so now we're fantastic, now we probably should merge. We now think it's all the same individuals, and images come in and keep on getting merged. And then comes suddenly discover that this is not the same individual. These two are not of the same individual. What do we do? Where do we find, where did we go wrong? How do we find that inconsistency? And how do we resolve, you and I, sort of now unmerge our data and all the inference that we made based on that decision? So there are problems when it happens within one data set, but we can rerun a lot of the algorithms. But when it happens across two conservancies, two research projects, based on public data, then it's a bigger problem. And so we can do data audit and rollback checkpoints and merge and split, which is an NP-hard problem. But there is also a lot of the data sharing and access control and identity management policies that have to be brought in, which Jim will talk about. Thank you.
Okay. Time for a quick question while our next speakers come up and sit up.
No questions.
I actually have a very naive question, only because I'm not familiar with the whole poacher side of things. But how tech savvy are the poachers?
Very. So there are several levels. The local on the ground are not that much, but poaching as an industry has just, so wildlife crime has just surpassed small arms trade as the third most valuable, economically valuable crime network. So it's the drugs, humans, wildlife crime, right? So and a lot of and I can give examples, and I'm sure others here can as well. So there are a lot of levels of tech savvy as you progress sort of in the level of poaching, and the value of what you're trying to get goes up, so does the tech savvy. Yeah. So they do hack into database. In Brazil, there are examples of hacking into a exotic bird database. There is tracking through the GPS collars and so on. So there's
Pick your brain a little bit.
Mm-hmm.
Thank you.
Get your microphone.